Solution of copper 2 sulfate contains blue copper 2 plus ions, sulfate 2 minus ions, hydrogen plus ions, and hydroxide minus ions from water. Electrolysis of the solution, however, will give different results depending on the electrodes that are chosen. If we use inert electrodes, for example carbon or platinum, at the cathode, copper ions are discharged. The copper coats the electrode. At the anode, oxygen bubbles off. So copper and oxygen are produced, and this agrees with the rules that we learn about the electrolysis of aqueous solutions. The blue colour of the solution fades as the copper ions are discharged. If we, however, switch the inert electrodes to copper electrodes, we get a slightly different result. At the cathode, you do again form copper, and that coats the electrode. But at the anode actually dissolves, giving copper ions into the solution. The anode dissolves because the copper atoms at the anode lose their electrons and the electrons flow back through the circuit. The ions that form go into the solution. So the anode is actually supplying copper ions. Now these then swim and move towards the cathode to form copper. So copper effectively moves from the anode to the cathode. Because you're constantly supplying copper ions into the solution, the colour does not fade. Now, the idea that we've just covered leads to two important uses of electrolysis. The first one is for refining, which is another word for purifying copper. Now, here the anode is actually made of impure copper, and the cathode is pure copper. The electrolyte is dilute copper 2 sulfate solution. Now, when the circuit is switched on, the copper in the anode dissolves, but the impurities don't actually dissolve. They just drop to the floor of the cell as a sludge. And this is really useful because that sludge contains precious metals, which can be extracted and then sold to keep the process profitable. So a layer of pure copper builds up on the cathode, and when the anode is almost gone, it's quite easy. You just replace the anode and the cathode. Now this is brilliant because the copper deposited on the cathode is over 99.9% pure, so it's really useful for any application that requires copper. And the sludge may contain valuable metals such as platinum, gold, silver, and selenium. And as mentioned before, these can be recovered and sold. Now, the second most important use of electrolysis is electroplating. And electroplating means using electricity to coat one metal with another to make it look better or to prevent corrosion. For example, in the picture that you can see, there's a steel tab and it's plated with chromium to make it look bright and shiny. Now, chromium does not actually stick very well to steel, so the steel is first electroplated with copper or nickel, and then it's electroplated with chromium. Now, this drawing shows how to electroplate a steel jug with silver. Now, a jug is used as the cathode. The anode is made of silver, and the electrolyte is a solution of a soluble silver compound, such as silver nitrate. So at the anode, the silver dissolves, forming silver ions in solution, and at the cathode, the silver ions are attracted to the cathode. There they receive electrons, and that's where they form a coat of silver on the jug. When the electrodes are connected to a power source, electroplating begins. When the layer of silver is thick enough, the jug is removed. So in general, to electroplate an object with metal X, the setup should be, at the cathode, you need to have your object that you want to electroplate. At the anode, you need to have metal X, and the electrolyte needs to be a solution of a soluble compound of X. Highly refined copper is used for the wires that are used to charge up tablets and phones, so it is highly likely that you have actually benefited from electrolysis while watching this video. Chemistry, we thank you.